Nobody was watching Starfall. Everyone had their eyes on Ship 40, the 70-meter upper stage sitting at Starbase, waiting for its static fire. SpaceX fans had been tracking the booster rollout, the cryo tests, and the 33 Raptor install. The whole community was locked in on Flight 13. Meanwhile, on the morning of June 23rd, booster B1078, on its 29th flight by the way, lifted off from Cape Canaveral carrying something that looked literally like a giant hockey puck. 3.1 meters wide, 75 centimeters tall, no wings, no solar panels, no communication dish, just a flat disk sitting on top of a rocket heading to orbit. SpaceX called it Starfall. The booster came back, landed on the drone ship, same as always. Routine. What wasn't routine was what had just been released into orbit. Starfall isn't a satellite, it's not a space station module, it's a return vehicle. A capsule designed to carry cargo up, sit in microgravity orbit while whatever's inside does its thing, and then come back down with the finished product. Pharmaceutical crystals, semiconductor materials, biological experiments, products worth millions of dollars, grown in the only environment where the physics work in your favor. And when I pulled up the spec sheet for the first time, I kept coming back to one line, the propulsion system section. It was completely blank. No deorbit engine, no Draco thrusters, no monopropellant, nothing to fire when it needs to slow down and fall out of orbit, a vehicle returning from orbit at Mach 25 with no engine. That's not an oversight, that's a decision. And understanding why SpaceX made that decision tells you more about where this company is heading than the hardware itself. Rewind to 2020. Varda Space Industries raises their seed round. The pitch is clean and logical. In-space manufacturing has been theoretically viable for decades, but nobody's built the return logistics for it. Their solution is a small capsule called Winnebago, with its own propulsion system, capable of autonomous deorbit and splashdown. Winnebago has thrusters. It can maneuver. It can independently select its reentry window. From a pure capability standpoint, it's the complete version of what a return capsule should look like. It also took them 4 years to get FAA clearance, partly because regulators spent a long time on one specific question. What happens if a thruster fires at the wrong moment, in the wrong direction, and the capsule comes down over a populated area? Uncontrolled reentry risk. It's a legitimate concern, not just a bureaucratic one. Starfall's answer to that concern is to remove the thruster entirely. No thruster, no uncontrolled firing. The entire reentry trajectory is locked in by Falcon 9 before Starfall is even separated. The kick stage positions it at exactly the right orbital parameters: inclination, altitude, phasing, so that atmospheric drag alone pulls it down into the target splashdown zone. The capsule doesn't decide where it lands. Physics does. A few cold nitrogen jets keep the heat shield face down during descent. That's their only job. Everything else is orbital math done on the ground before launch. With zero room for error, SpaceX already operates Dragon, a capsule with full deorbit capability, flying since 2010, FAA approved, infrastructure fully built. Why spend the time and money designing something new from scratch? The answer is in the mass. And once you see the numbers, the logic becomes unavoidable. Dragon weighs 4,200 kilograms empty. Its Draco thrusters, propellant tanks, and all associated plumbing account for roughly 800 kilograms of that. That's about 19% of its dry mass, dedicated exclusively to the deorbit burn. Starfall weighs 2,100 kilograms empty. Zero propulsion mass. It's half the vehicle for the exact same orbital mission profile. But the geometry question is much more interesting than the mass. Why a disk? Why not a cone like Apollo, or the bell-shaped Dragon uses? It comes down to the lift-to-drag ratio, or more specifically, the intentional suppression of it. A high lift-to-drag vehicle, like the Space Shuttle, generated aerodynamic lift during re-entry. That lift let it maneuver horizontally, cross thousands of kilometers, and land on a runway. Powerful. It also required 24,000 individual thermal tiles across the entire ventral surface. Every single one was a maintenance nightmare. Apollo didn't try to fly during re-entry. It fell, controlled by its blunt face shape alone. Maximize drag early, decelerate fast, take the heat load in a short burst. It's simpler and more reliable. Starfall takes this even further. The disk geometry maximizes the ratio of surface area to volume. For the same payload volume inside, you get a larger heat shield area outside. More area means the same total heat energy spread across more material. Lower peak temperature per square centimeter. It sounds counterintuitive, but the flatter and fatter the vehicle, the gentler the thermal environment for everything inside. You're not fighting the heat. You're spreading it thin enough that it stops being a problem. Now, here's the detail that most coverage skipped entirely. Starfall's heat shield, the carbon fiber ablative plate at the bottom that weighs roughly 700 kilograms, is designed to be jettisoned after peak heating. Dragon's heat shield stays on all the way to splashdown. It's a structural element. It absorbs the heat, then floats in the ocean attached to the capsule. Starfall drops it mid-descent. The ablated, roughened surface creates turbulent wake conditions that complicate parachute deployment. And after peak heating, the thermal protection job is finished. You don't need 700 kilograms of ablator hanging off the bottom anymore. You drop it, open the chutes, and come down lighter. SpaceX has been applying this exact logic since 2008. Once a structural component has done its job, it goes. The Falcon 9 fairing was the exact same decision. Now, to be fair, the heat shield material details haven't been fully disclosed. From what's publicly available, it's an ablative composite optimized for the disk-specific reentry profile. That means a shallower entry angle, longer heating duration, but lower peak flux than a conical capsule. The exact composition? SpaceX isn't saying. Compare this with Varda Winnebago, a real capsule doing real missions, but with roughly 100 kilograms of return payload capacity. Starfall returns 1,000. That's not just a marginal difference. That's an order of magnitude. It's the exact same difference as a single-engine Cessna versus a Boeing 737. Starfall on Falcon 9 is the product, but Starfall's geometry was clearly designed with a different vehicle in mind. Starship's payload bay is 8 meters wide, with roughly 17 meters of usable interior length. Starfall is 3.1 meters wide and 0.75 meters tall. Stack the numbers. You can fit 8 to 12 Starfall units inside a single Starship cargo flight. One Falcon 9 puts one Starfall in orbit. One Starship seeds an entire fleet in a single flight. Ship 40, the upper stage for Starship Flight 13, completed cryo-proof testing in May. 6 Raptor 3 engines are installed. It's being moved to the pad right now for the static fire campaign. Booster 20 is back in Mega Bay 1 getting its 33 Raptors installed. The target window is July 2026. The FAA's mishap investigation from Flight 12 is still open, so that's the wild card. Now run the numbers on what this actually means. Starfall generates commercial revenue on Falcon 9 now, while Starship is still being developed. That revenue funds the Starship program without having to wait for NASA contracts. More Starship flights prove reusability. Proven reusability drops launch costs. Lower launch costs open the Starfall market to more customers. More customers generate more revenue. Reusability reduces cost. Lower cost enables more flights. More flights prove reusability. That's not just linear improvement. That's a compounding loop. And SpaceX just added Starfall as the financial engine running it STOL. The in-space manufacturing market sits at roughly $300 million annually right now. Industry forecasts put it at $30 billion by 2035, and that forecast was built on the assumption that return logistics would remain expensive and infrequent. Varda, ATMOs, Sierra Space, they're selling boutique access. High price, low frequency, and limited mass return. They serve the customers who absolutely have to have orbital manufacturing and can afford whatever it costs. Starfall's entry doesn't attack them directly. It builds the layer underneath. Commodity access for customers who couldn't justify the trip before. It's the exact same move Amazon made when it built its own fulfillment network. Amazon didn't attack FedEx or UPS. It built the infrastructure to make certain shipments so cheap that FedEx's pricing model became irrelevant for that tier. SpaceX is doing the same thing. Except the commodity being democratized isn't two-day shipping. It's access to the manufacturing conditions of zero gravity. Now, there's a fair criticism worth sitting with for a moment. Starfall's heat shield is expendable. The structural capsule, the aluminum top plate, the nitrogen system, the parachutes are theoretically recoverable. But the heat shield itself, 700 kilograms of carbon fiber composite, goes into the ocean after every single flight. That's not full reusability. At least not yet. SpaceX's bet is that manufacturing Starfall units at scale drives the per-unit cost low enough that partial reusability is acceptable, at least for this phase. The heat shield becomes a consumable, just like ink cartridges in a printer. Everything else you reuse. It's the cartridge business model, applied to orbital cargo return, so it all comes down to the static fire. Ship 40's engines fire for the first time in the next few days. The data from that test, the chamber pressures, propellant consumption, any anomalies, will determine whether Flight 13 gets a July launch window or slips to August. Both outcomes move the story forward. Neither outcome breaks the plan. Let's go back to that blank propulsion section on the spec sheet. The one that kept bothering me at the start. It turns out the empty field isn't a gap in the design. It is the design. Removing the engine is the entire point, because when you strip a spacecraft down to only what it needs, no extra systems, no redundant thrusters, no mass that doesn't earn its place, what's left is cheaper to build, faster to manufacture, and easier to certify. And that is the manufacturing philosophy that lets SpaceX scale this into a real logistics network. Ship 40's static fire is coming. Booster 20 is getting its engines. July is the target. And once Flight 13 flies, and if the booster catch works for the second time, the entire cost curve for Starfall shifts. How much it shifts and how fast, that's exactly what we'll be watching. If you want to be there when that happens, you know what to do.